Hello students. In the first part on vector algebra, we had studied the representation of vectors and the section formula. In the second part, today we are going to study the dot product of two vectors, which is a very important topic. So watch the video till the end. The link to the first part on vectors is given in the description box. We have already studied that for a given vector A, the vector A cap, which is the unit vector, is given by the vector upon its magnitude. And second thing we have already studied is the section formula when a vector divides a line segment joining two vectors in internal ratio and in external ratio. Vector algebra consists of vector addition and vector multiplication. Vector addition combines the vectors by adding just their corresponding components. Vector multiplication can be done in two ways. When a vector is multiplied by a scalar, then there is change in magnitude but not in direction. Second case, when a vector is multiplied by a vector, two possibilities. First one is the dot product. Dot product or the scalar product it results in a scalar value, and it is calculated by multiplying the corresponding components and then adding them together. Dot product is a very important topic, and today we are going to discuss all the types of examples based on it. So please do subscribe to the channel. So how will we define the dot product of two vectors? The dot product of two vectors A and B is given by A dot B is equal to mod A into mod B into cos theta, where mod A and mod B are the magnitudes of vector A and B, and theta is the angle between the two vectors. Now by the definition, it is very clear that since the magnitude is always positive, the dot product depends on the sign of cos theta. Correct? Now, if you want to find out the dot product of two vectors, given the vectors in the form of component form, then the dot product A dot B is equal to AX BX plus AY BY, means you just multiply the X component and add it to the multiplication of Y components. Since the answer of dot product of two vectors is a scalar quantity, it is sometimes called the scalar product. Second observation is that if the dot product of two vectors is 0, the vectors are perpendicular or orthogonal. You know why? Because cos theta is 0 when theta is pi by 2. That means the vectors are perpendicular to each other. Dot product is commutative and distributive. And where it is used mainly to find the angle between two vectors or the projection of one vector onto another. I've given a simple example over here where the vectors are mutually perpendicular to each other. You will be able to prove this as we move on to the different examples. So we again revise the definition of dot product and solve the simple example which explains the concept. To calculate the dot product of two three-dimensional vectors, you multiply the corresponding components and sum the results, as I told you. So suppose if you are having two vectors, a vector A which has components A1, A2, A3 in the three directions, vector B which has components B1, B2, B3, then dot product A dot B is given by A1, B1 plus A2, B2 plus A3, B3. Now, as I told you that one of the main application is to find the angle between the vectors. Suppose you need to find the angle between the vectors I minus 2j plus 3k and 3i minus 2j plus k. Then using dot product, the definition of dot product says A dot B is equal to magnitude of A into magnitude of B into cos theta. So basically you know that if I write this in the form of magnitude of B into magnitude of A cos theta, correct? So from this what I get is cos theta is equal to vector A into vector B upon their magnitudes. So first we find vector A into vector B. How will you find that? You just multiply, as I told you, the different components and then add them. Correct? So for the given two vectors, 1 into 3 plus minus 2 into minus 2 plus 3 into 1. This is equal to 10. This is the dot product. What is the magnitude of A? Magnitude of A means root of square of all the components. So it is 1 square plus 2 square plus 3 square into the magnitude of B, which is 3 square plus 2 square plus 1 square. So magnitude of A into magnitude of B is equal to root 14 into root 14, which is equal to 14. So now cos theta is the dot product upon their magnitudes. So it is 10 upon 14 or 5 upon 7. So theta will be cos inverse of 5 upon 7. This is how we can find the angle between two given vectors. The second application is to find the projection of a vector on a line. So suppose if we are having a vector AB, which makes an angle theta with a given directed line, say L, in the anti-clockwise direction, then the projection of vector AB on L is a vector, say P, with magnitude as magnitude of vector AB into magnitude of means into mod of cos theta, and the direction of P is the same or opposite to the given line depending upon cos theta is positive or negative. Then in this case you call your vector P as the projection vector and its magnitude is given by mod of P, and it is called the projection of the vector AB on the given directed line L. Now in the diagrams, if you see in the first figure, it is given that the angle is between 0 and 90 degree. So the projection vector is P and your given vector is vector AB. In the second case, your angle is between 90 degree and 180 degree. In the third case, it is between 180 degree and 270 degree. And in the fourth case, it is in the fourth quadrant, means the angle theta is between 270 degree and 360 degree. So in each of these cases, the vector P is the projection vector, and we will see with the help of examples how to find the magnitude of the projection vector. Now the formula for projection vector. The projection vector for a given vector A is given by vector A into P cap, where P cap is the unit vector along the line L. If you want to find the projection of vector A on another vector B, then it is given by vector A into B cap, where B cap is the unit vector, and you know by formula unit vector is the vector upon its magnitude. So A into B cap can also be written as A into B upon magnitude of B, or first you can find out A dot B divided by the magnitude. So this is the formula of projection of a vector A on another vector B. Now some properties. Now since we have the definition of A dot B as B into A cos theta, if your theta is 0, that means the projection of AB will be AB itself. And if it is pi, then the projection of AB will be BA, vector BA means in the opposite direction. If your angle between the vectors A and B is either pi by 2 or 3 pi by 2, then the projection will be the 0 vector. Now we will start with the example. So the concept of dot product is clear. First application, find the angle between the vectors A and B if the magnitudes are root 3 and 2 respectively, and their dot product is root 6. So by simple formula, you know that cos theta is A dot B upon magnitude of A into magnitude of B. So cos theta is equal to, just put the values 1 upon root 2. So theta is cos inverse of 1 upon root 2, and you know that at pi by 4 cos theta is 1 upon root 2. So theta is over here pi by 4. So the angle between the given two vectors A and B is pi by 4. Next example, if A is a non-zero vector of magnitude A and say you have lambda is a non-zero scalar, then lambda into A is a unit vector if which of the following condition is satisfied. Now since you want your lambda into A to be the unit vector means by definition vector upon its magnitude. So lambda into A should be equal to A upon magnitude of A. So in this case, your lambda should be 1 upon magnitude of A, or A should be 1 upon mod lambda. Why mod lambda? Because you know that the magnitude of the given vector is A and magnitude is always positive. So even if lambda is negative, you need to find the value which is positive. So it is 1 upon mod lambda. So the answer is option D is true. Your A should be equal to 1 upon mod lambda. In the next example, we will show that the given 3 points are collinear. How will we show that the three vectors are collinear? If magnitude of AB plus magnitude of BC is equal to magnitude of AC, as I have shown in the diagram, then the 3 points ABC will be collinear. So very simple, just find the vector AB, vector BC, vector AC, correct? And then find its magnitude. So how to find vector AB? AB means it is from A to B. So the x component of vector AB will be the difference of B minus A 2 minus 1. Similarly, y component 6 minus 2, z component 3 minus 7. Similarly, find the components of vector BC and the components of vector AC. Now it is very clear over here that when you find the magnitude of vector AB plus magnitude of vector BC is equal to magnitude of vector AC. Hence the three vectors are collinear. In the next example, if A, B and C are unit vectors such that vector A plus vector B plus vector C is the zero vector, then find the value of AB plus BC plus CA. Now you're given that A, B, A, C are unit vectors, so the magnitude of each of these vectors is 1. Also, it is given that A plus B plus C is the zero vector. Now, you can do it by any of the methods, but the easiest way of solving this example is since you want A, B, B, C, C, A, so what you do is first of all you multiply A plus B plus C by vector A. That means vector A into A plus B plus C is equal to vector A into 0 vector because of what is given, and that is equal to 0. So what we have obtained is A dot A bar A dot A plus A dot B plus A dot C is equal to 0. But what is A vector A into vector A is nothing but magnitude of vector A whole square. So since it is given that magnitude of vector A is 1, obviously magnitude of vector A whole square is also equal to 1. So what we have obtained is the first equation, which is AB plus AC plus 1 is equal to 0, or vector A into vector B plus vector A into vector C is equal to minus 1. Similarly, by multiplying by vector B and multiplying by vector C, we will be getting two more equations. You just add these three equations, so you will be getting 2 into AB plus AC plus BC vectors is equal to minus 3, or vector A into B plus A into C plus B into C is equal to minus 3 by 2. Hence, the value of vector A into vector B plus vector B into vector C plus vector C into vector A is equal to minus 3 by 2. As we know that the other application of dot product is to find the projection vector. So find the projection vector of the vector I plus 3j plus 7k on the vector 7i minus j plus 8k. So we have seen the formula of projection of vector A on another vector B is given by A into B cap, which can also be written as vector A into vector B upon magnitude of vector B. So first find vector A into vector B. You know that how will you find the dot product? Dot product is found by multiplying the each of the components and then adding it. Means 1 into 7 plus 3 into minus 1 plus 7 into 8, which is equal to 16. And what is magnitude of vector B? Root of the square of the components. So for root of 49 plus 1 plus 64, root 114. So now by definition, your projection of vector A on vector B is A into B cap, which is equal to dot product of vector A into B upon magnitude of vector B, which is 60 upon root of 114. So the answer is the projection is 60 upon root of 114. Now, from the concepts of dot product, try to solve these examples. In case of any query, please put in the comment section. In the first example, you need to find the angle ABC for the given 3 vertices. And in the second example, you have to find the magnitude of the vector x. In the next part of vector algebra, we are going to study still a very important concept, which is the cross product of two vectors. So please do subscribe to the channel.